to introduce Budha, and he is also a part of the ATC Discord community. And the topic today is Linux. And without further ado, I will now pass this on to Bit.
Thank you. It's a pleasure being here, definitely. Because I've been a part of ATC for like probably 2-3 months. So we do this thing called the intercambio. So it means like language exchange pretty much. So every Thursday we be speaking like in Spanish, and then we talk about tech, and then in like Korean. So it's really cool for anyone who's like interested in like language and tech and cyber. It's just a really cool spot to like be. But yeah, and Linux is like my love. So I'll definitely be like sharing my love for like the next hour pretty much. Because Linux is something that made tech like 1,000 times more interesting to me. This PowerPoint, and then we'll post the links as well so you guys could like follow along. Linux lessons, right? And this is cool because this is a PowerPoint I did at work a while ago. I'm just like redoing it, right? And I feel like these things are really important. But yeah, Linux lessons. So firstly, before you even speak about Linux, right, we got to go way back, right? So this was in the 1960s, 70s, right? So this guy, Thomas and Dennis Ritchie, right? They were working on this thing called Multics at AT&T Bell Labs. So you guys know Benjamin Graham Bell, the guy who kind of like helped make the phone. He had made this thing called Bell Labs, so they made it in his name. And then they were working here, right? And they were working on this thing called Multics, which is Multiplex Information and Computing Service. So this was like way back in the day where like mainframes were the thing, right? Thomas and Dennis Ritchie, they made the C programming language, right? Which is like what a lot of kernels and operating systems are still built on to this day. And they made Unix, which was like kind of a newer version of Multics, which they were working on as well. Bell Labs, Ken Thompson and Dennis Ritchie, the Multics stuff just wasn't working well. So then they moved to Unix, which was actually written in assembly. And I love assembly too. Assembly, just a quick caveat, assembly is like the closest level you could get to the hardware, right? So it goes like assembly. So like, all right, so there's the CPU, the central processing unit, right? And it's doing like, they have these things called transistors, right? And the transistor is basically like an on and off switch, right? And then each CPU has like billions of transistors, right? And assembly basically takes those ones and zeros of the transistors being like on and off, and it gives mnemonics for it. And mnemonics is basically like several letters that reference something else. So instead of typing 01100 or whatever the heck, you'll have a mnemonic that represents that binary code, right? So assembly is like it goes like this, the hardware CPU binary, right, which is like the ones and zeros, like the on and off switches and the transistors. Then that's assembly, the mnemonics. And above assembly, they have C. And they used to actually call C high level assembly because it basically was like the same thing as assembly, just a bit more abstracted. Then after C, we got into the higher stuff like the Pythons and the JavaScripts and the Ruby on Rails. Like you got into more abstraction where you don't have to be confined to the hardware anymore. You can just make your code and they can run in the browser, for example, for JavaScript. So that's like a quick, just like summary of the high level languages like JavaScript and Python, and the lower level languages like C and assembly. So like the closer you get to the CPU and the hardware, it's a low level language, but technically it's harder, right? And the higher you get to like the Python and the JavaScript, it's more abstract and it's a high level language. But yeah, that's a quick like summary of that because I think that's important. It was rewritten in C, making it portable on different machines. Also, this was a really important caveat because back in the day with assembly, right, it's really tailored towards your central processing unit, right? Your CPU, right? But then once they moved to C, you could port it from your Mac OS to your Windows to your like Linux, right? And C made it so you're not tied down to your specific hardware all the time. You don't have to redo everything for your hardware. You could port it from this computer to this computer to this computer. So it was a really beautiful transition. This was started at the universities mainly. So BSD, Berkeley Software Distribution, it's like a cousin to like Linux. So I'm gonna go into Linux more during this talk, but like Unix is kind of like the grandfather. And then Linux, BSD, and even Mac OS are like the cousins and the grandchildren of like the Unix kind of philosophy. So yeah, the Unix principles live on in Mac OS, Linux, and Android, and many server systems in modern day. So that's a quick summary of the Unix history. And also, like, if you have any questions, you could like pause me. I could go more in depth. I think this is important. This slide is probably one of the most important slides on this whole entire deck because usually when people speak about Linux, right, they go straight towards like, it's not like Torvalds, the guy who made kind of Linux. It's not like he was sitting in like a vacuum and he made everything from scratch, right? He was building on the principles that he learned from other people, and he was building on even the software that other people already had, right? And Richard Stallman, right, he created the GPL, right, which is a more so integrated the free software foundation. And these philosophies and frameworks is what let Linux like exist. Because the beautiful part about Linux, especially, it's not only free, right, but it's also open source, right? And that means that anyone on the planet could right now, right, they could go view the Linux kernel code anywhere on the planet for free, right? And you could also download it for free, right? With the GPL, the GNU public license, right? It means if you get the software, right, you also have to be willing to distribute the software in a similar state, pretty much. Like, it goes a bit more in detail, but this was kind of the framework. And Richard Stallman's dream was to basically create an operating system that's not like bogged down by all these proprietary, big tech, closed source, like patented software and hardware, right? So this was his dreams, right? So he was gradually building it out with him and his team, right? And this was like it was kind of like a perfect, not even a perfect storm, it was like a perfect rainbow, right? It was like Richard Stallman already had this dream of like creating this operating system, and then Linus came about and added the rest of the stuff to it. So the thing that Linus did, I'll basically go in it. So good luck, GNU. GNU stands for GNU Not Unix, which is a free Unix-like operating system, right? So Richard Stallman saw what Unix was doing, and he was like, bro, I'm gonna do the same thing, but I'm gonna make it free and open source, right? He doesn't like the proprietary nature of software. For example, you can't look at the Apple code. Like if you have an iPhone, right, you can't like be like, hey, Apple, let me see the internal of the Apple kernel or operating system. They're gonna look at you like you're stupid. Like, what do you mean? Like, we're a multi-billion-dollar company. Why would we give you our code for free, right? And in some senses, that makes sense, right? But if you're more about like sharing and community and grassroots, that didn't make sense to Richard Stallman. So that's why he started the Free Software Foundation in 1985, right? And then he kind of just like shared a lot of these philosophies. Also, what's important here, the GNU compiler collection. This is critically important because almost, I would say 70 to 80% of software, right, when it's compiled and when it goes from higher level interpreted languages or whatever, object-oriented language, it's compiled down, right? Everything goes back down to assembly or C. It goes back then to C assembly, then binary, right? And the GNU compiler collection literally is like the final translator, right? So a lot of the programs we use, they're using this stuff for free because Richard Stallman just gave it to the world for free, right? But it compiles down to that. So this is hugely important for like pretty much all software, pretty much majority of it. And he also made GNU Emacs, which is like a text editor in an environment that's almost like his own operating system in a sense, because you could do a lot. You could have your own browser, you could do text, you could do a lot of different stuff with it. Well, he contributed to GNU Bash shell. I'm gonna go into that a bit more later. And this right here, the core utils, right? So ls, cp, grep, these commands, right? These programs are literally like the foundational, most popular Linux commands, right? If you go online and be like, oh, what are the most used Linux commands? These things are what are coming up. ls basically means list. It lets you list the items in the terminal. CP means copy, so you could copy a file from here to there. And grep basically helps you search for strings or search for text inside a file, right? So if you have a long file and you're like, hey, I want to see that paragraph with Kenya in the title or whatever, right? You will type in grep then like Kenya or whatever, and then it will pop, and then the file name as well. And it will show you what line did that text come from. Anyway, these things are important, right? And this is why I feel like I had to put these slides about Richard Stallman, because we're using these commands every single day. If you've ever tested Linux for like even 10 minutes, you've used these commands, right? And I feel like we have to put respect on what he has done, because I feel like he's often left in the shadows, because Linus took a lot of Linus is important, but he took a lot of the public acclaim and fame, which is warranted because Linux is like the kernel and it's really, really important, right? But I feel like we also have to give a credit to the GNU and Free Software Foundation and Richard Stallman for creating these programs that we use on a daily basis as any Linux person or even a cloud person in general, right? The GNU system was nearly complete, but lacked a working kernel. That same year, Linus Torvalds released the Linux kernel. So to give an analogy, it's like Richard Stallman and his team did like 75%, right? Imagine like a donut, right? He did 75%. He did the whole donut, right? And then Linus Torvalds said like, hey, this donut needs a kernel. And he put this kernel right in the middle which completed and created like the Linux like kernel and operating system, right? Because it's kind of like both in a sense these days. And Linus basically added the last 25, boop, and then he got the credit for all of the other like 75. But both are important, and I feel like that's why both of their names have to be brought up before we even speak about commands, before we even speak about distros, before we even go on to all that stuff. This is important, right? GNU/Linux. People don't really say GNU/Linux, right? Because either they're trying to just be, quick, right? They're not thinking about it too deep. But I even try myself to just like add that, right? Because it is important. I feel like not enough people add that as well. So it's a combination of GNU tools and Linux kernel formed what many call GNU Linux a fully functional free operating system, right? So that is that part. One and only Linus Torvalds, right? So this guy, he was looking at Multics, and he was looking at, there was this one other one he was looking at as well. And he was like, bro, I can make my own kernel. Because back then there was this whole debate of like micro kernel versus like micro kernel versus monolithic kernels. And Linus was like, bro, I could just do this myself. Because he was at the University of Helsinki. And he was like, bro, this is cool, but I could pretty much do my own thing. I could pretty much do my own like kernel. I don't need the one that my school is using. That's like, I believe the one there was proprietary. It was like it stemmed from the Unix family. He was like, bro, I'm gonna just do it on my own. So that's pretty much what he worked on just for himself. He wasn't thinking about making it for the world. He's like, bro, I think this is cool, so I'm gonna do it for myself, and I'm gonna just do it. Also, he created Git, which is like a version control system, which is pretty much all like majority of what software engineers use. Either use Git or GitHub, GitLab or Giteria, whatever. They have all these different versions of it now, but he created like the foundation of it. And Git, a version control system is very important, especially if you're collaborating on your code or your software. So basically, say I make this code, right? It's like I make 10 lines of code, right? And then I want to change something. If I'm doing it by myself, it's easy, right? But say it's like 100 people working on the same 100 lines of code or whatever, right? And Sally Sue wants to make an edit on line 50, and Benjamin wants to make an edit on line 10, and Kevin wants to make an edit on line 19, right? It's going to get very convoluted very quickly. And that's why Git was created, to kind of have multiple, not firstly to track your code. Even by yourself, it's important to track your progress, because sometimes you edit code you didn't want to, and you want to revert back, and Git let you do that. Or you just want to have different branches to try out new software, but not have it on the main branch. So Git basically helps you have multiple branches and see the edits, let your teammates collaborate on it and see which code fits the best. So Git and Linux are like basically like universal in the software industry. So shout out to Linus Torvalds. But yeah, he's the father of Linux. He started in 1991 and licensed by the GPL. Going back to Richard Stallman, the GPL is literally the license that helped create Linux, right? So they both go hand in hand. Here's a quote by him: making Linux GPL was definitely the best thing I've ever did, right? So the guy who made Linux said, hey, this GPL that Richard Stallman made is literally the best thing I've done, right? So it was a huge thing. In modern day, we have like a lot of Linux-based desktop environments like KDE and GNOME, which are very popular. Yeah, so he was a Finnish student at the College Helsinki over there, and he used the GPL. Both him using the Linux kernel and the GPL and the GNU core utils, like those popular commands, basically made like the entire Linux system. Some earlier distributions. So it's important. I'm gonna just say this quickly. So a distribution is basically a version or flavor of Linux. So imagine Linux as like ice cream, right? A lot of people like ice cream, right? So say you have ice cream, right? And then Deshawn, he wants the chocolate ice cream. Then Rebecca, she wants the strawberry ice cream. Then I want the vegan ice cream, right? So it's like everyone wants a different version of the ice cream, right? And basically they all have different like benefits, right? Example, Red Hat, if you're using Linux in like an enterprise server, like multi-million-dollar company, you have 1 million Sun servers, you're probably using Red Hat Linux, right? Because it's made for enterprise governmental servers, right? It's made for more so server side. It's not usually used for desktop environments, like personal use. It's used for like massive servers, right? So Red Hat's popular for that. If you want stability, Debian is like it. Debian, like it's it, because it's like the old grandpa that's like still fit. He's like the 90-year-old that like he's super old, but he's still like doing push-ups every morning. He's still running track, you know. He's the guy that's stable and like old, but he's still healthy in a sense, and he's not as risky as a new distros. Slackware, I haven't used Slackware much myself, but I believe in Europe it's a lot more popular. over there, and it's really like intricate. So Linux became dominant in servers, supercomputers, and embedded system. This is the other thing. In the desktop environment, I think people say like Linux is like 5% now, probably 6%, but which is fair, right? But on the server side, Linux is like everything, like majority of your servers, right? And a server in the cloud. So a server is basically like a computer that sends information, pretty much. It's like you're in a restaurant and you have your server. A server is like that. Like, hey, I want spaghetti, but instead of spaghetti, hey, I want this YouTube video, or hey, I want this PNG image, right? And the server's like, hey, here you go, right? That's what the server does. So every server that's doing that, like 80-90% of them are running Linux. So Linux is huge. Also using Android. If you have an Android device, you're using Linux. If you're in the cloud, you're using Linux. If you have IoT, if you have like a Alexa or a Google Home or whatever the heck, you're talking to your Alexa, turn off the lights. That's Linux, right? So everything in the background, majority of it is like Linux. Even if you're into cyber, Kali Linux, right? The ethical hackers are using it over there. So a lot of people are using Linux. If you're like a super technical person, you can't escape Linux. Like it's something that you should learn early. Yeah. This is one of those things that is like water. Like you can't escape water. Like it's going to rain, right? You got to drink water. It's like, you can't escape Linux. So I feel like it's best to embrace it as much early on. This is just the Linux kernel, right? The kernel is basically the heart or the center of operating system, right? I believe it's like 3 billion lines of code now at this point. Like that's a lot. It's a lot of code. They've been working on this stuff for like 20, probably like, pretty much like 30 plus years now. Yeah, like 30 plus years pretty much. Yeah, or around that. So it's huge. And we have people around the world contributing to this kernel. Actually, I have a Linux kernel. The Linux Foundation has a Linux kernel development and Linux system admin course that I'm actually going to be taking in a couple months. But this stuff is stuff I'm going to get deeper into because this is like, and this is stuff you will never, like as a normal Linux user or Windows user or Mac OS user, whatever, right? You would just not see this stuff. This all stuff is like under the hood. This is stuff that you will never see unless you're like Linux kernel dev. Because even if you're on Ubuntu or Kali, right, could go into this stuff, but it's really intricate and it's stuff I have to learn a lot more about. But this is just the kernel, not even speaking about the desktop environment yet. So the kernel is huge. You know, they have like stuff for like processing, human interface, memory, storage, networking system, and all these kernel devs work on a different part of the kernel. It's like one of the biggest open source massively contribute thing on the planet I know of, genuinely. Like I know there's a lot of open source stuff, but the Linux kernel, this is the foundation of like a lot of things. Like it's almost mind-boggling to think about it. So Linux is huge, right? It probably doesn't get as much marketed or acclaim as the Windows because Windows is dominated in like the personal use desktop environment. But for people who like are more technical and people who run servers, Linux is basically like the lifeblood of all of that. Oh yeah, so the Linux kernel versus the operating system. So the kernel is a core part of the OS, the operating system, complete system, including the kernel. The function for the kernel is to manage hardware and system resources. The function of the operating system is to provide user interfaces and applications. The kernel, no direct interaction. So user access, like this is stuff you usually don't do. You usually aren't in the kernel, unless you're a kernel dev, you're usually not touching that stuff, right? And then the user access for the operating system is your GUI and your shell, right? You see, click here and open Google Chrome and watch cool cat videos, right? That's all the GUI operating system stuff, right? The Linux kernel, I believe, yeah, we're at 6 now. So this is like, it has like versions. Like it has like the same way that your phone or your video game might have an update. The kernel has updates as well. And some popular operating systems that run in like Linux kernel or Ubuntu. Fedora is interesting. Fedora is basically upstream Red Hat. And what does upstream mean? So, you know, say we're at a river, right? Further up the river and Angela's further down the river. And I toss some mangoes into the river, right? And it gradually is going to go down to her and then she will pick up the mangoes, right? In the Linux world, it's similar. So you have your kernel devs and your distributions that are upstream, right? So Red Hat basically pulls from Fedora. So Fedora is me at the top of the stream, tossing in the mangoes, like, oh, these mangoes are so cool. I want Angela to have them, right? And then gradually downstream, Angela is like Red Hat. She will get those mangoes, like, oh man, these mangoes are so cool. Thanks, like upstream devs. So the upstream software devs, right? They're the people who are working on like the kernel, working on things that are really like more hardware based, right? So all the cool software stuff we see in the browser and the desktop, we have to think they're the kernel devs for that because they're in like the pits. They're in the pits, like making that stuff for us. So shout out to them. So you have your kernel, your applications, and the kernel interacts with like all of this stuff. It's kind of like the middleman. between that, because the visuals help me understand a lot. So I hope it'll help you all as well. So you have your hardware. There's like your CPU, your RAM, your hard drive, and all that stuff, right? Your mouse, your monitor, printer, right? And then you have your kernel, right, which is inside that, or on top of that. And then you have your shell, and then you have your applications. And I'll go a bit more into what the shell is as well. So the shell is a command line interface that lets users interact with the operating system by typing commands. It acts as a bridge between the user and the system core, the kernel, right? This is the other thing. The shell, you're closer to the kernel, right? Because you're doing the command straight to it. It's like you type a command, you go straight to the computer's heart. Or basically, you could view it as the computer's subconscious. It's like you're speaking to the computer's like subconscious in a sense. It's like you're speaking to it in its dreams. It's like, bro, like type this command and then pop it on the screen, right? So like I like being on the shell. I like being on the command line interface. Like that's like my homeland pretty much because it just feels better and it's a lot more minimalist. If you're not a fan of like this huge big tech advertising, targeted marketing, AI go in the terminal, bro. I always use an analogy. Being in the command line interface or the terminal is like being in a cottage in the woods where no one is at, right? Being in the GUI, being in the browser is like being at Times Square at New Year's Eve, right? Where it's like 1,000 people, right? And there's so much chatter. But in the terminal, it's like a black screen. So like the commands you have in your head, you're like a wizard. Hey, do this. It pops on the screen, right? So it's pretty cool. So we have the Thompson shell, which was made in like 1971, the Bourne shell, 1979, and the Bash, created by the GNU project, became the default on most Linux systems. If you use Linux, you're using a shell, right? And Bash literally was created by the GNU project. So Richard Stallman and his friends, they literally like, hey, we're going to make the shell. And that's one of the most important things in Linux pretty much. So that's why I'm saying it's unfair to separate the Free Software Foundation, the GNU project, from Linux. Because literally they're embedded in Linux for some of the most important features on it. So it's really important. Some modern shells we have are Z shell and Fish. So they have different shells based upon like the type of interface you want. This is a terminal, right? I wanted to use this image to stay in your mind, right? Because now you will go on Ubuntu, you go on Red Hat, you'll go on Kali, you pop up, oh, I'm popping up the terminal, I'm popping up the shell, and you feel like a hacker. You are a hacker, right? Shout out to you. But it's important to know history as a hacker as well. And this used to be an actual terminal that used to connect to the mainframes and the other computers, basically. So this was the middleman between the computer, the actual computer, and the human. You had this terminal, and then the terminal would link to the computer, and you would type here. But in modern day, our computers got so advanced where we basically abstracted all of this. We have virtual windowed terminals now, right? Which is cool. But back in the day, oh, you know what's funny? I said you're a hacker. I didn't even realize on the monitor says hack a day. But that's cool. Xbox. I'm actually looking to that. Posted. What was this? Oh yeah, this was a while ago. 2088. Oh, I don't know. But anyway, so this is like an actual terminal, right? This is like a bit more history of it. So you had your physical terminals, which are like telewriters or CRTs, right? To connect to the mainframe computers. Then we went to the virtual terminals, the software based, right? So it pops on your screen like a window, like, you know, like the window pops on your screen like that. Terminal emulators as well. Like GNOME is a popular one. I've used GNOME. If you're using Ubuntu, you're most likely gonna be on GNOME. I've used Console before. If you're using Kali Linux, they'll probably give you Console. I've used RxVT. So like all of these things are very similar. A visual demonstration, they're pretty much the same stuff. They're just kind of like slight little tweaks. And then they have Alacrity and Terminator and all of that other stuff as well. And they have TTYs, which are virtual consoles that exist. So a TTY, if you're ever lost and you're like trapped, a TTY will save y'all a lot because this happened to me a few times. Sometimes you won't be able to get to your GNOME terminal. You won't be able to get to your console. You won't be able to get to RxVT, right? Because they're kind of like bricked or whatever. But your TTY is kind of like a backup if those don't work. This is a terminal, right? You've probably seen this like, ooh, hacker, oh my God. Save me, right? Save me, right? But it's actually not that complex. And I will do so he did ping, right? He looked at the Wikipedia. He pinged the Wikipedia server to see if it's active or not. PWD, which stands parent working directory, I believe. And he's in the root directory, right? This is his name. His name is root at localhost, right? CD means change directory. So he changed directly into the var. A directory is a folder. If you're coming from the Windows world, a directory is a folder, right? So he changed into the var folder. LSLA makes it a long format and lists all the hidden files. So these are basically a list of the files inside the var directory. Yum, he's most likely using Red Hat, Fedora, CentOS, Alma Linux, or Rocky Linux. So also there's package managers, right? And each package manager has a different name. And Yum, I believe, is like an older version of DNF. So it's like a Red Hat package manager. And he's like searching for this, if this package manager has Wiki in it, and Wiki is like a program. And then it seems that it does. And he's like, it seems that he's installing it now. So that's pretty much it, right? I know it might look crazy, but like, oh my God, this is so much. But like, honestly, it's not that crazy. Like, it's really not. So once you get used to it, it's pretty simple and straightforward. Command line interface, yeah, kind of some of the stuff we was talking about before. The boring shell, the born again shell, the command line interface. Like, this is a command line interface, right? But it's also a terminal. So I feel like this is why the terms get so confused, because it can be both, right? But now since we have virtual terminals, I feel like it's more confusing. But remember, this is a terminal, right? That gets you to the command line interface, right? So they're kind of like, water and H and H2O. It's kind of like the same thing, just in a slightly different context. Yeah, so these are kind of like the differentiations between them, like console shell, command line interface, terminal. So I'm gonna stay here for like a bit so you can like probably just read it. So GNOME is a terminal. The shell is bash, Z shell, fish, kish. The command line interface is like the actual, like where you type the commands at, like ls, cd, mkdir. So yeah. Also, this is really important. So when people are teaching you Linux, right, they're going to be like, oh, ls, cd, cool, right? Firstly, they don't go through the history. I just went over the history. The history is important, right? Also, they don't go over the keyboard shortcuts. As a person who loves Linux, right, this is something I'm getting better at. I'm trying to put you all on the right path. Learn the keyboard shortcuts before you even do a ls, before you even do a if configure, IP config, right? Before you even do all this fancy stuff, right? Learn the shortcuts, because these shortcuts are universal. And if you learn these, you'll be a lot more efficient. Because this is I had a command line interface. If you do these shortcuts, you can basically move like quicker, right? You don't have to do everything. For example, delete previous word, right? This way here. See, I had a word, right? And I had a 5-letter word. I had to go delete, 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 delete. Or you can just press Alt backspace, delete the entire thing, you know? So it's just like a quicker way to like move around. And then these are a couple popular commands, like cd changes the directory, clears the screen of any of like, so like example, you will really find quickly in Linux, it will kind of be overwhelming, right? You could just clear all this. So if you type clear or just erase all this and go just back to a black screen, and I'll do a quick demo after this as well, just going through these really quickly. CP copies the file, diff compares the content files. Say you have one Python file and the other Python file. You have one C file or another C file. I'm like, hey, what is the difference between this? Because they have the same like file name, right? So you, like, what is the difference, right? It will tell you if the difference. And there's ones that go really intricate. It will tell you like literally if one like aspect of one line is different, it will let you know like the difference, right? Especially if you're working in software dev stuff. It's more to like the one line can literally like be an entire bug that you're trying to solve for a week. Right? So sometimes you got to find the differences between the stuff. Exit is important. So if you're trapped, sometimes exit won't work, right? So if you exit won't work, if you're you just want to exit your terminal as leave, exit is the first choice. If that doesn't work, Control C could help you exit sometimes. If that doesn't work, Control Z helps you exit sometimes. If that doesn't work, Control X helps you exit sometimes. So there's a lot of things that's kind of, because you will get yourself in like pits, like easily. You're like, oh man, like I ran this program and now I can't type anything on my screen. Press Control X, press Control D, press Control Z, and it'll kind of like exit you out. Grep, speaking about this earlier, if you have a text file and you want to search for Uganda, right? Because you're reading a book about Africa, like history. Anyway, if you want to search this one string, there's one text, you just put grep, the file name, and also the thing you want to search, and it will pop it up. Head displays the top 10 of a file. Less displays like helps you view the text file like line by line. ls lists the contents in the file directory. mv moves one file to another directory or one file to another location. rm deletes a file. rmdir removes a directory, but also feel like you have to force that because sometimes you probably guys press rmdir space -f sometimes to force it, because sometimes it doesn't always work. Tail lists the last 10, list the last bit of a file. So if you use the example, you want to find the last paragraph for this book or whatever, right? You press tail, then the book name, and then it will list the last 10. Tar is basically like an archive, right? Format to just kind of make things like shrink a bit. is example, you need like more space or whatever. Tar and zip, like tar and zip are basically ways to kind of like compress and like make archives of things. And you have to transfer a lot of files. Vi is like a text editor, which I love, which I'm about to show off. And it's basically the same stuff. Parent working directory. Touch helps you create a file. Migdir helps you make a directory. Sudo, this is more right here. Sudo, it is you like run as system administrator. If you coming from the Windows land, right, and you had a program you had to run as admin because it wasn't working normally, this is the same thing pretty much. Man is very important. Your manual pages, if you ever get trapped and don't know what a command does, press man, then the command name, and then it will give you a description of it. Cat basically lists the contents of a file, like in the terminal, like very quickly. Echo displays like the text or variable that you just type. So if I put echo Mingos, right, it'll pop up on the terminal. I like Mingos pretty much. Chown changed the ownership. So on Windows, this is the thing too. Like, and even outside of Windows, you know how some people have like read access. Example, say I have a Microsoft Google Doc, right? And I send it to Angela, but I want to only give her view access. Or I want to give her edit access, or I want to give her this access, right? In Linux, the files are similar. So you can change the file permissions, file ownership. df shows the disk space. du shows the directory space usage. Top is like a task manager. If you're coming from Windows line, you can see all of the processes. PS is a similar thing, but top is like, it looks better pretty much. It's just something that looks more fancy. It kind of does the same thing. And kill terminates the process. I think that's the last slide. So from that, LS, right? This website, we'll put it in it's called labex.io, right? And it has all these different Linux labs you can use in your browser. So it's a pretty cool way to start. Uname, right? If you want to know, who am I, right? Uname and who am I? Uname, I'm Linux, right? Who am I? Labex, right? So that's like your username. So it's basically telling you like you and your operating system like kind of name pretty much. So those are pretty straightforward, right? What's an LS? You probably use this nonstop. It lists what's in the directory. But the question is, what directory am I in? Right? So if you type pwd, print working directory, I'm in the root directory. Right? Imagine a tree. You know how the tree has like branches, right? The root is like basically the trunk, like the root of the system. It's like where everything falls back to, in a sense, right? And if I want to change to a new directory, see, so everything in the blue here is a directory, right? Everything in the blue are files, or no, folders I could go into. So if I type cd home, I'm going to the home directory. Now, you see, I'm in the root directory in the home folder, right? So I'm in the home folder in the root directory, right? And then if I click ls again, I could go to Labex, which is like the username, right? Labex, right? Now, I'm in the Labex user, right? And we could go to the desktop because everyone is, we know how, like, what desktop is. So if I cd to the desktop, now I'm in the desktop, right? So if I type pwd again, right? So I'm in the desktop folder, inside the Labex folder, inside the home directory, inside the root, right? All right, so I'm gonna type clear, like clear my screen, clear, right? Clear. And then I'm gonna type pwd again to just make it simple. So I'm in my desktop, right? See, these are the things in my desktop. I have terminal, I have gedit, I have gvim, graphical vim, I have code, right? I have all this stuff on my desktop, right? And inside, I'm in the desktop folder, in the Labex folder, which is the username, and the home in the root, right? So that's kind of how to read these. So when you see this dash, it basically means in between directories, basically, or if you're in the root directory. And what's the other one we have? CD. I'm gonna type CD. So CD means for change directory. See, change directory to a specific path, right? So if I click dot dot, or if I click CD dot dot, so if I click CD dot, what happened? Nothing, right? So dot is your current directory. So I'm basically, you're staying in the same file. Maybe if it's CD dot dot, it'll take me back. So I took you from the desktop directory back to the Labex directory. So now if I type pwd, I'm in the Labex, right? And if I type ls, see, now I'm back here. So this is basically a way to move between directories, right? With ls, with cd, with cd, right? And now let's toss it out. So I'm gonna go back to the desktop, right? cd, change directory to my desktop. pwd, I'm in the desktop, right? Now if I type mkdir, say I wanted to make a folder. You know how on Linux you like right click like, oh, I want to make a folder on my desktop. I'm doing the same thing here, right? But I'm not doing it with a mouse. That's the other thing about the terminal. It's all keyboard shortcut based, right? It's something to like keep in mind. So mkdir, and then say, give me a word, Angela.
Mangoes.
Yo, let's go. Some mangoes, right? Mangoes. And also, this is a quick tip I will give you. With every directory I make, this isn't needed. Like I don't think anyone will tell you this, but it'll kind of help you keep visual track, especially if you're in a terminal that doesn't have color, because that was sometimes happen. So we're fancy now, right? We're fancy because we got color, right? But sometimes we're not even going to have color. So if you want to like find out what's the difference between this and that, and you don't know, if you type in mangoes.dir and I click ls again, now I know that this is a directory. Why? Because I put .dir. So any file you make, any directory you make, I highly recommend you name it with like a file extension, like a 3-letter file extension. Example, and I can also do touch. So if I want to make touch, let's say a banana, right? No, banana. Touch strawberry, right? .txt. I'm gonna make a text file now. Boom. But where is it? Here we go. So then you got to type ls again. And now you see I have strawberry.txt, I have mangoes.dirt, right? Now, say hypothetically, if I wanted to move strawberries.txt into mangoes.directory, right? So say, imagine you're on Windows. So I feel like a lot of people are coming from Windows, right? You have a text file and you have a folder, right? Usually you would just click the strawberry text file and then slide it into the mangoes file, right? But here we can't do that, right? So I do MV, it stands for move. And if you type, other cool thing, if you type the first letter of something like tab, it will pop up. If there's other like files of S, it will like, if you keep pressing tab, you'll basically like shift like through them, right? I'm moving strawberry.txt into mangoes.dirt. Boom, ls. Now the strawberry isn't there no more, but where did it go? So I go back into the mangoes, change directory into the mangoes directory, boom, strawberry.txt right here, right? It seems simple, but you got to realize this could be done on a larger scale. The thing about the terminal, it might seem very simple and tedious at first, but if you're doing this with like 1,000 files, you could automate this. Like everything I'm doing here, you could put into a bash script to automate, and you don't have to even click a mouse or a terminal. You just like run it immediately. It kind of does it. So that's the beautiful thing about Linux. It might seem tedious at first, but you got to understand, these people are with like servers with like millions of files, right? If you're going through millions of files and got to go through millions of directories and you want to automate it, this is when you could take these commands into a bash script and automate all of this. So you don't even have to click, you don't have to do this. But if you're just doing it like we are now, you could do it like this way. And what else we have? I don't want to make another file. So touch cheeseburger.txt, right? So I make a cheeseburger file, but the thing is, I don't like cheeseburgers, right? So what I'm gonna do, I'm gonna remove it, right? I'm gonna remove the cheeseburger because I don't want it in like nowhere near me, right? So remove cheeseburger, right? So then RM stands for remove, right? And then wait, let me go to this. So if you remember, I said if you just type C, then tab, you don't gotta type the whole thing, and it makes it easier on you. Then poop. Now the cheeseburgers are gone, and now we're healthy again, right? So that's an easy thing to remember. What else? Also, we have clear for Control L. Ooh, remember what I was saying? Wait up. Remember, cow. All right. So remember I was saying, learn the keyboard shortcuts, right? So there's two ways I could clear the screen. I could probably CLEAR. Which took me 1, 2, 3, 4, 5 letters I had to type to clear the screen, right? But now if I'm gonna clear it, I can type Control L. Bop. I just saved 5 keyboard presses. And I know people are like, bro, you just do these type over 5 keyboard presses. But if you're a software person, you understand this little improvement. If you're doing the stuff day after day, week after week, year after year, that 5% keyboard press you don't gotta make is saving you time. It's all about efficiency, right? In software development, right? And just in Linux in general, it's all about being efficient and smooth, right? So learn these keyboard shortcuts because they'll save you time. So we did ls for list, right? CD, Oh, also, if you type CD by itself, it brings you back to your home directory, right? So I was just in the Mangoes. I was just in desktop, right? And then I was in Mangoes as well, right? I was just here, right? Pink directory. I'm in home, Labex, desktop, Mangoes. But if I click CD, it puts me back at Labex. So that's an easy way to just get back to your home, pretty much. You could go deeper into files. You see what I'm doing here? Like I said, look, CD, D, tab, right? M, tab, right? So that's a quicker way to do things. You're just like, boop, I'm gonna go to this folder, boop, I'm gonna go to that folder. You don't gotta do it one by one. You could just hop to a folder that's like 50 directories away if you want, you know? And then you could just get back there and then Control L, clear my screen again. CP, okay, that's important. CP, so say I'm doing a strawberry fast. Next week, I'm only eating strawberries, right? And I wanna copy this. So I'm copying strawberry, and then actually, I could just name it strawberry 1. Now we have strawberry and strawberry 1. Echo, I like fruit. Bow! I like fruit right on the terminal. Of course, the echo command is actually pretty in-depth. You could actually add a lot more to it, right? But that's, especially if you're using bash scripts, you can basically make the script basically ask the user when they run it and basically prompt the bash script to say something to the user. So this is popular if there's an error, right? And you write a bash script and you want the error message to pop up, you put echo, oh, we can't find this file or this error is popping up. So it will let you know, which is very beautiful. What else? DDF. Hooey. So this shows this space, right? So this is kind of similar to going to your computer and seeing how much you have. Is it kind of DFS8? Okay, this shows it in like human readable format. Like the thing I just did was like I believe they call it like a flag or like a switch, right? One of them. 20 gigs, bro. We live in life, bro. We got 20 gigs, living life, big money, you know? So you're looking good, you know? And then this kind of shows the different directories and file paths in it as well. And then if we do DU, DU shows, oh, well, in our directory, we don't have anything, right? But if I go back, say I'm gonna go back to the root folder, right? So now I'm in the root directory again, and I do DU. It looks crazy, right? But it's literally going through all of the files on this virtual system and show me things. And this is actually a good time to show what I was talking about. So if I try to type exit, I can't. Oh, wait, no, let me do it again. If I try to type exit, I can't because it's moving so fast. But if I could do Control C, bow, exits, right? Let me do it again. And if I could do Control Z, bow, it exits. And if I do Control D, nah, Control D, or Q, nah. So Control C, right? And Control Z, right? If you're ever trapped and you can't exit something like this, you have like 1,000 things popping on your screen. Bro, how do I leave? I can't type exit. Control C, brother. You're all right. You're all right, brother. You're cool. Control Z, brother. You're good, sis. Like you're good. You know, you're back in the terminal. You're chilling, you know? So that's like pretty cool. What else they got? They got top as well, which is kind of similar to Task Manager. You see, we can see all the different programs running pretty much. And then even with this, I'll type Q. All right. So it's either Q, Control C, or Control Z, right? To like exit stuff. If I type top, I could just do Control C again. It was it type top, do Control Z, or exit again, or do top and press Q and now exit. So there's a lot of ways to exit this stuff. PS is kind of similar to top. It just shows like a couple of the processes. So I'm running Z shell, like the shell we were talking about earlier. I'm running top, I'm running PS, I'm running DU. So these are like the commands and programs that's run. And you can also kill like programs. But now I think those are the main commands. And then now I want to really more go into why for the last 10 minutes or so we have. All right, because some Control L to clear the screen. List, where we at? I want to go back to where I want to go. I want to go, and if you keep pressing tab, you see you could pick where you want to go. So I want to go to desktop. Besides desktop, I want to go to Mango. See? Wow. And we're already there. And then list. Let me just type one. Now the screen is black, right? And there's a meme in software that we're like, oh, like I spent a month trying to exit Vi. Like, how do I exit Vi? Oh my God, blah, blah, blah. Like, if you ever get trapped, right? All you gotta do is Q. Who sees? Anyway, Q, right? Q could like help you exit. Even me, I like almost got trapped.
All work. They all work.
Yeah. I almost got trapped in Vi myself. Jeez, it's pretty intense. All right, so let's do Vi. So say I want to add text to strawberry, right? Vi strawberry.txt. right? Now I'm in strawberry.txt, right? See at the bottom, strawberry.txt, right? So Vi is a text editor that's solely keyboard shortcuts and a solely keyboard shortcuts and commands, right? So it's very scary to people who are used to like a graphical user interface, right? But I love it because if you're a person who spends time in a terminal, this is basically your home. Because Vi basically, if you have a Linux system, 9 times out of 10 is gonna like just come with Vi. It's just like a universal thing. It's like an evergreen skill because it's like universal. But say I'm gonna type text, right? So I click I, which stands for insert. I like strawberry, right? And now I'm just click 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, come on. 18, 19. I like blueberry. And I'm doing this for a reason, right? And once I'm done with insert mode, I click escape on the top left, right? And now I'm back here. Now if I click this and WQ, it should write, which stands for save, and Q, which stands for quit. Okay. Now if I click head, strawberry.txt, it lists the top of the file, right? Now if I click tail, strawberry.txt, it lists the last 10 or so, right, of it. Now if I click cat, strawberry.txt, it's gonna list the entire file, entire text file. If I click, is it on here more.txt? It's kind of similar to that. If I click less.strawberry.txt, it's gonna show the same thing, but usually if it's a longer file, you could like go through it. It will like, you could gradually go through it, like skim it, like scan it. And then like the way like a printer comes out and you gradually go through, it do the same process. So that's pretty cool. And on Vi, there's a lot of other stuff you could do as well. It's pretty intricate. Like, oh my God. Actually, the way they have their setup is interesting. But anyway, I'm not clicking the up and down arrows. I'm clicking H to go left, K to go up, J to go down, and L to go left. And then it's like, why can't I just use the mouse thingy, like the mouse pad? Like, why am I doing all this extra? But if you're a touch typist, you want to have your fingers as close to the home row as possible. So that's why Vi was kind of made in that generation where people were so keen on touch typing. So that philosophy has stayed with us. That's kind of a quick thing of that. Also, it's a lot. Like now, you could basically jump to a new. Now clicking Shift O. This means like you go upwards, and then you can click D to like delete. There's like a ton of different commands. I'll actually on my desktop I might have it. Yeah, my desktop. These are all of the different commands that. Yeah, so it's really intricate. Like when I say it's really intricate, like it's super, 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 super. Linux, and I love. If you're a human being who interacts with technology, right? I definitely recommend it. Thank you to like Angela for getting me on here to speak about this stuff because I actually love this stuff genuinely. Because Linux is like an evergreen skill. If you learn Linux, I guarantee you, just the way you will engage with technology will change, right? You will be able to be a producer and creator, right? So it's something I really love. Especially like in the future, I'm gonna get more into like Linux system admin stuff and Linux kernel development stuff. But right now I'm studying like data engineering while pivoting in cyber a little bit. So it's a lot of stuff I'm studying. But yeah, we'll post all that stuff in the links later. And Angela, if you had any like last questions or remarks or recommendations, you could.
Thank you again, Bit, for that wonderful presentation and demonstration. I think a lot of folks are going to benefit from this, especially if you want to get into cybersecurity. Yes. Knowing Linux will put you ahead above those who don't know it. And I feel like it's really good for CTFs as well, because you do a lot of challenges and you're trying to look through the files. Good pen tester is a good system administrator. So, and systems administrators love using Linux.
Yes. Yeah, this is major. Yeah, like especially if you're in like getting into the whole ethical hacking, penetration testing, you're going to be using Kali Linux, Parrot OS, or Black Arch, right? And they're all like on Linux. So they're all like Linux-based like systems anyway. So this is better. Like they say in life, if you do what is easy, your life will be hard. And you do what is hard, your life will be easy. And I feel like Linux is the perfect representation of that. Because it might seem rough. Like if you're a person who only like you're used to like the mouse stuff, right? Or like only the touchpad stuff. It's like, what do you mean this black terminal command thing? It's so like obscure. It's so scary, right? Like once you get comfortable with your fear of the unknown, once you get comfortable with your fear of like the black screen, in the dark or whatever, there's a lot of light after that. Like there's a lot of beautiful things that you could create from there. So it's a beautiful thing to know.
Also, be shared in the description box as well as our community Discord. We're growing in numbers each day.
No, it's muy bien. It's muy like rico, you know. It's really beautiful. It's really rich, you know. This community and space. So if you're into tech, if you're into cyber, if you're into like learning languages, Linux, anything like that, join us. I'd love to have you.